You hear me? So first of all, you have nanograms, and it's easier to just turn these into kilograms or grams if you want. So you could do it twice. Nano is a billionth, which is 10 to the negative 9. So you'll want to make this 10 to the negative 9 times. So to get rid of nanograms, you have 10 to the negative 9 grams for every nanogram. So the way this conversion is done, because you have nanograms in the multiple, remember I said multiples are like this, so it's one number divided by another number, or it's multiplied up here. So there's top and bottom. The bottom is the divisor. So here you want to get rid of ng, and you have, so you want to get rid of ng to get to kg. We're just going to go to grams first because it's nanograms. So from nanograms, make it smaller. Basically, this is a bigger number than it is. Make it smaller, so you go 10 to the negative 9, which is what nano is. Nano. And once you do this, basically you're multiplying by this number. Then you're going to have whatever grams. Then you take that number and you want kilograms. So you put how many grams in a kilogram. Because this is in the top, you divide by grams. And there's 1,000 grams in a kilogram. Kg1. So now when you multiply this is a multiple of 1 over 1,000. So you're dividing by 1,000 really, but it's a multiple still, whatever. So you take this number, divide it by 1,000, and that gives you kilograms, and that's it. So 2 times 10 to the 4. You basically just take the 9, add it to this, and you get 2 times 10 to the negative 5. Then you're adding, basically this is probably confusing, but 1 over 10 to the 3. Same thing as 1,000. So here you would just subtract 3. So you go 0 times 10 to the negative 8 kilograms. No, it didn't become 4. This is just this problem here. Then from here, you go here. So you take the -9, add it to the 4, and you get this -5. Then from here, from this -5, you take away another 3, because it's 1/10 to the 3. It's dividing. So because it's dividing, you just take it off instead of adding. Yeah. So like, let's say you had let's say you had 1,000 milligrams, 2 grams, or 6.0 to micro. Grams per mole. So 1,000. Yeah, so what they did was they took this 6.0 mg to put it to grams. A gram has 1,000 milligrams in it. So this is 10. When it's 1,000, basically you're dividing by 1,000, because the measure you have, okay, like a milligram, let's say, is that. This is a gram. So if it's 6 of these, it's going to be less than a gram. So you divide by 1,000. Like if you had 6 of these milligrams, it's less than a gram. So you divide by 1,000 to make it to grams. Milligrams, grams. And then once they did that, they divided this by 1,000, or in the way they showed, they multiplied it by 1/1,000. And in this conversion factor, you do the same thing. So you have milligrams in the top here. This is the top, right? So you put milligrams in the bottom here. There's 1,000 milligrams per every gram. So once you do this multiplication, this and this cancel out, and you're left with grams, and basically you're just dividing by 1,000. So it's 6 divided by 1,000 grams. Then to go from grams to moles, you have, this is the weight of it, the molar mass. So let's turn this into, let's write this in scientific notation. A thousandth is a 10 to the negative 3. So once you divide this by 1,000, it's the same as doing this. So it's 6, you can write 6 times 10 to the negative 3. 10 to the negative 3 is 1 over 1,000. Just count the zeros, 1, 2, 3. You can go like, you know, the other way, like you can go times 1,000 is 10 to the 3. You probably know that. But so now you have this number, and you want to go to moles. So you have this many grams, 10 to the negative 3. And you multiply, well, you have something grams per mole. Here you have grams. I think it's the opposite of this. Yeah, so it's the opposite of this. So you go 6 times 10 to the negative 3 times 1 mole, 180 grams. So the reason for this is it's grams per mole, but you have grams, and you want to get rid of grams, so these now would cancel out, and you're left with moles. And this is a division, so you divide this number by 180 because you have 1 here. This is a 1, and that's a multiplication. So 6.0 times 10 to the negative 3 divided by 180. That's how many moles you have here. And then this is in moles, and you want to go from mole to micromole. Micro is 10 to the negative 6. No, 10 to the negative 6. So you have this number, micromoles, let's say you have a mole and you want micromoles. You have the bigger thing, you want to go to the smaller thing, so you divide. Or do you multiply? Yeah, you multiply. If you have, like, let's say a quarter of this, you have way more micromoles. So you multiply the number. So the number gets bigger because your unit gets smaller. So this number times the conversion to micromoles, so 10 to the negative 6. And this is micromoles per 1 mole. It is a thing, but this is a 1, so it doesn't matter. Your mole here and here cancel out, and you're left with micromole. So your last answer should be 6.0 times 10 negative 3 divided by 180 times 10 to the negative 6. 10 to the 6. Yeah, this is wrong. It's not negative 6, it's plus 6. It would be negative 6 the other way around, because there are more micromoles in a mole. There are less moles in a micromole. So if you're going this way, from micromole to mole, you go negative. So if you have one, let's say you have one, no, let's say you have 30 kilometers per hour, and you want meters per second. So basically, just think of top and bottom. So you want meters per second. So you want seconds on the bottom, and you want meters on the top. To get meters from kilometers, you divide by 1,000. So there's 1,000. So you multiply by 1,000 meters in a kilometer per kilometer. Now, because you have kilometers in the top here, you want kilometers in the bottom. And this is the conversion, so you have 1 kilometer. For every 1 kilometer, you have 1,000 meters. So the reason you put it here is because you want to get rid of kilometers, top and bottom, and you have 1,000, so you multiply this by 1,000. You have 30,000 meters per hour. Now you want per second, how many meters per second? You have hours. You could do it all at once, 3,600, or you'll do 60. So you have 60 minutes every hour. Over here, you have hour on the bottom, so you can't do this. You'd have to write hour on top for sure, because you want hour to be gone here and here. You want them to cancel out. So you have 1 hour. In every 1 hour, you have 60 minutes. So these cancel out, 1 and 1. This is a 1, this is a 1. They cancel out, and you have 30,000 divided by 60. So you have 3,000 divided by 60 meters per minute. And yeah, okay, 500 meters per minute. And now you want seconds, and you want it meters per second. So meters per second. You want seconds on the bottom, and you have minutes on the bottom. There are 60 seconds in every minute. You have minutes on the bottom, so you put minutes on the top in 1 minute, and just write the conversion, so there's 60 seconds. Now this and this cancel out, and you get, yeah, 8.33, 500 divided by 60. So from nanomole per liter to micromole, so you want this micro per deciliter. Okay, so basically nano is 10 to the negative 9, and micro is 10 to the negative 6. So you want to go from negative 9 to negative 6. Basically you're adding 10 to the 3, you're adding. So whenever it's 10 and 10, they're the same base, so you can just add the 3 to the negative 9. Nanomoles. So you could write this, because it's nano and this means this, you could write 890 times 10 to the negative 9 moles per liter. And now because you want to get to micro instead of nano, okay, because micro here, because nano is smaller than micro, say this is the micro, nano to micro, you have a smaller number, you have a smaller amount of something being a part of a bigger thing, so it's going to be smaller. Your value, like if you have 5 nano whatever, it's only going to be like half in micro, not really, but it's going to be smaller. It's going to take up a smaller section of this whole nano mole, so your number is going to get smaller. So instead of 10 to the negative 9, you're going to take away 3. So it's going to be 8, 9, 0. So you're going to basically divide this by 1,000. It's going to be this times 10 to the negative 12 moles, micromoles per liter. So because you're using a larger measurement, your number is going to get smaller. Like a meter is going to be 1,000th of a kilometer because you're using a bigger measurement. So now you want to go from liters to deciliters, and there are 10 deciliters in a liter. So you want so there's 10 deciliters in every liter, and you want to get rid of liters, so you put liters up here for sure. It's in the bottom here, so you want to put liters here for sure, and then you put 10 deciliters, and that's basically your number divided by 10. So dividing a number by 10 just makes it that much, makes it smaller by 10, like makes it smaller by 1 magnitude of 10. So actually this would be 890 times 10 to the negative 13. You just go from negative 12 to negative 13. And that's the answer. Micromoles per deciliter.